Welcome to the second video. We just got 3 examples. And then in the third video, we got 3 more examples. In the fourth video, we got 3 more examples. So hopefully got the tools to prepare you for this stuff. Example 3. Evaluate. We'll start with the integral. This is part A, the integral from 0 to 1/2 of just dx over the square root of 1 minus x squared. Again, you have so many formulas for integration. Sometimes we simplify, sometimes we use a u substitution, sometimes now we have formulas for inverse trig that look kind of weird, that are not obviously inverse trig. And that's what we have here. A u substitution is not going to work because our guess for u would be this, but there's no x on the top. If there were an x on the top, then yeah, we'd use a u substitution. But because there isn't, u substitution is not going to work. We're going to want to use one of these formulas. So which one does it look most like? Inverse sine. So let's copy that down again, because we're going to need it. And having it nearby will be helpful. So recall that the antiderivative of du over the square root of a squared minus u squared is the inverse sine of u over absolute A plus c. So we're pretty close. Just have to identify some things. In this formula, A is just equal to 1. And u and x are the same thing. So we can just evaluate this formula. We don't even have to use a u substitution. Substitution. It sounds like I'm going to make a cool song or rap. I have made a math rap before, but probably not going to bring it up in Calc 2. So here we go. I have given a live performance in class though. So yeah, this is just the formula directly. No u substitution necessary. It's already in the right form. So we know that the antiderivative is going to be inverse sine of our variable. Our variable is x here, not u, by the absolute value of a, which is 1, plus it's a definite integral. We'll evaluate this between 0 and 1/2. And that'll give us inverse sine of 1/2 minus inverse sine of 0. Remember your inverse trig. Right? May have to take a trip down memory lane. I got tons of trig videos too. Because your calculator a lot of times can give you a decimal approximation, but we want exact answers. Sometimes your calculators can give exact answers too, but it's useful to be able to do it by hand. So this is saying the sine of what angle equals 1/2. And specifically, the sine of what angle in the domain of inverse sine. Remember all these trig functions, right? We want an inverse function for these trig. But for an inverse function to exist, the function has to be 1-to-1. It has to pass the horizontal line test. This doesn't pass the horizontal line test, so what we did in trig is we said we're going to make it 1-to-1 by cutting out everything that fails the horizontal line test. Usually centering things at 0 and preferring positive numbers. So this is, sine goes on infinitely long, but this is what we restricted it to. So the domain of inverse sine, the numbers that we're looking for here are going to be between -π/2 and π/2. All right. So this guy in red is equivalent to that. And if you remember your unit circle or your special triangles, you should get the answer here is π/6. And it's going to be positive π/6 because we need a positive angle. So this is going to be π/6 or 30 degrees minus inverse sine of 0. Follow the same logic to get 0. Our final answer should be π/6. Next problem. We'll do more trig review in this next problem too. or in the third problem. Part B says, what's the antiderivative of 1 over 1 plus 4x squared? Again, u substitution won't work here because if this is our u, there's no du anywhere. There's no x term on the top to substitute out. We can simplify this a little bit, but it really does look a lot like this trig integral. Not exactly the same, but close. So let's copy that down, copy that formula down and see if we can use it. We know the antiderivative of du over a squared plus u squared equals 1 over a inverse tangent of u over a plus c. So we need to rewrite this integral for it to look like this. So a can just be 1. That's fine right here. We can write this as 1 squared if we want. And write this as 2x squared. Right? 2x being squared is 2x times 2x, which is 4x squared. That's great. So if u is 2x, then we have it in the right form. So now we'll u sub. Let u be 2x. So the derivative of u with respect to x is going to be 2. So du is just 2 times dx, which we don't have, but we can get it. Multiply by 2, divide by 2. Now everything in blue is just du. We get 1/2 times the antiderivative of 1 over 1 squared plus u squared du. Here, a is 1. And now we can use this antiderivative formula. Now we're going to get 1/2 times, again, a is 1, so that term will go away. Inverse tangent of just u, because a is 1. So it's u divided by a, but a is 1, plus c. And u, well, we know what u is. It's 2x. And hopefully that's the right answer, but if we're ever in doubt, we can check by taking the derivative. The 1/2 stays right there. Derivative of inverse tangent is 1 over 1 plus the thing squared multiplied by the derivative of the inside. This is looking promising. We get cancellation. We get 1 over 1 plus 4x squared when we simplify, which is exactly our integrand, and that's exactly what we're looking for. Looking good. Let's do the last problem for this video and then have another one. The integral from root 3 over 3 to root 3 of dx over 1 plus x squared. So again, a is 1. We don't have to use a u substitution at all. This is just inverse tangent. This is just the formula for inverse tangent. Same matching formula as with our differentiation. So it is just inverse tangent of x, and it really just becomes a matter of, well, do you remember your trig? It's just the evaluating that's hard here, not the calculus. It's the trig. We get inverse tangent of root 3 minus the inverse tangent of 1 over root 3. You can write it in either form, 1 over root 3 or root 3 over 3. They're the same. I like the 1 over root 3 form more because it works with the special triangles that I have experience with. One of the triangles is 30, 60, 90. Pi over 6. Pi over 3, 90. Short side, hypotenuse, and long side had these ratios. So the tangent of one angle is root 3. Pi over 3. Opposite over adjacent is root 3. And again, that's what we're looking for here. Again, you have to watch out for your domain. But in general, the way that you start these problems is ask yourself, well, the tangent of what angle in the domain of arctangent? So make sure to note that in domain of arctan, tangent of what angle is equal to root 3? Special triangles and unit circle will get you there. Our winner is pi over 3. Tangents opposite over adjacent. We get pi over 3 for the first one, and then we are subtracting. The second one, well, it's just going to be the reciprocal. So it's going to be this angle now. Opposite over adjacent, 1 over root 3. So pi over 6. 30 degrees, sorry, 60 degrees minus 30 degrees is 30 degrees. And that's our final answer. And that's our final answer. All right. So let me know if you have any questions about these. You can work on some more problems, or you can watch some more videos. Up to you. We got plenty of them for you. Good luck.